Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions. Today we have two special guests. First up, we have Travis Oliphant. Travis is the CEO of Quansight. Travis, would you please go ahead and introduce yourself?
Sure. Hi, everybody. I'm Travis Oliphant. I'm a founder and board member of Anaconda, and then a founder and advisory board member of NumFocus, currently CEO of Quansight, and I've been involved in a number of open source projects over the past 20 years I'm very passionate about.
Thanks, Travis. And in addition to Travis, today we have Saul. Saul, would you go ahead and introduce yourself too?
Hey everyone, I'm Saul Shanabrook. I've been working at Quansight for a little bit now and working on Xnd. So I'm really happy to be here and thanks for having us, Anthony.
Oh, no problem. So we're normally for open source directions, before we dive into the meat of the episode, we have a brief headline section. So let's go ahead and we'll go around the table and just list some recent headlines that we've found interesting. Saul?
Sure. So there's a project called Lerna, which is a monorepo kind of management tool for JavaScript, and it's actually something we use in JupyterLab. And earlier this week, or last week, I guess it was, they changed their license from MIT to MIT minus people who collaborate with ICE, or people who work at businesses who collaborate with ICE, the Immigration Customs Enforcement in the US. It didn't stay like that for very long, maybe like a day or so, but the discussion that it brought up was interesting because it relates to how we as people who make general tools can have influence or not over how those tools are used and the ethics around that usage. So I'm interested in where that discussion will go.
Thanks, Saul. Yeah, that's very interesting. Travis?
Thanks. Yeah, I'm excited by the recent NumFocus organization announcements. There's board selection process they went through and kind of a new design board selection process showing the maturity of the organization. And 5 great new board members have agreed to join, and we're nominated and selected. And it's really great to see them join the Andy and Lorena who are continuing. And I'm just excited by the NumFocus board and the staff and all the work they do behind the scenes and all the volunteers that make PyData and everything work in that organization.
Yeah, excellent. Yeah, it was great news. For my headline this week, I would just like to bring to the attention of everyone Pyodide, which is something I recently heard of, which is the Python scientific stack compiled to WebAssembly. So some really interesting and great work coming out of Mozilla and Mike Dropboom, etc. So be sure to check that out. And so now we're going to go through and describe and introduce XNDs through a series of questions. So we'll just go ahead and dive in. So first off, Travis, why was XND started?
Oh, thanks. Yeah, XND is part of a sort of a saga of the past 6 or 7 years where I've been trying to figure out how to make NumPy better, how to improve the ecosystem around NumPy, how to improve the issues. Whenever you write a library, it's really awesome. You go through a lot of learning, and then you realize, 4 or 5 years later, man, things should have been a little bit different. Darn it. And now what to do? How do we make changes in that ecosystem without disrupting the lives of millions of users of NumPy today? So that's kind of the idea. And what this particular idea is to take the core components of NumPy, the type system, the container of raw memory, and low-level dispatch mechanism, and then refactor them into low-level C libraries that can be reused by other languages. And then secondarily, write Python bindings that could be reused by developers of other Python libraries. So XND is meant to be essentially the capabilities of NumPy refactored to be used by others. And so it's not a replacement for NumPy because it's not really a user-facing tool. So that was the idea, was to create some developer libraries to help people build NumPy-like things in many ways.
Very cool. And Saul, what need does XND fill?
So right now, kind of how we're thinking about it is that people in Python who use NumPy, a lot of them are just users who want to, maybe achieve some kind of, do some kind of algorithm or, have some kind of use case that they're doing that's pretty high level. And for those people, XND is probably not the right tool for them. XND is the right tool for people who are building array libraries. So Like the ragged array library in Python is a new effort to sort of talk about more different types of arrays besides just blocked kind of arrays. Like if you have raggedness, or if you have structures in your arrays, or more like nested kind of structures, how can you do computation on that efficiently? So
Right.
Xnd is helpful in that kind of use case because it provides these low-level primitives that from Python that allow you to do computation on more flexible computation on data than NumPy does, in the way that it allows for variable dimensions and more types of nesting. And it also has, as Travis said, C libraries that can be used in other languages. So if you're in another language and want to do some array computation by using the existing Xnd libraries, then you can kind of leverage all that work that's been done and just build the language binding. So then you can get access to all the computation kernels that people have written or created for Xnd and Python in whatever language that you're targeting.
Awesome. That's excellent. So Travis, are there any alternative projects that are out there?
That's a great question. If you're talking about sort of containers of data, there's a lot of them. TensorFlow, Torch, MXNet, all the way to Pandas and NumPy. If you're talking, and then Xtensor, for example, if you're talking about kind of the idea of a set of tools to support other array libraries, I don't know. I mean, maybe some of the machine learning libraries, TVM, NNVM has some building blocks that could be, if you squint, kind of related. So there's kind of associated projects, I think, cousin projects. Then, of course, there's other related projects like Arrow, which I've often called a cousin to Xnd. It's a particular kind of container that's particularly optimized for data frames and for data analysis. And Xnd tends to be about describing any kind of container. And more, we're starting with the ND array concept that can then contain anything. But you can also describe a collection of pointers to ND array to objects as well. So it's quite flexible, and in theory, one could write an Xnd description of an Arrow container. So,
yeah.
but that hasn't been done yet, and it's just theoretical. But that's kind of the idea: is could we use this system to really describe dispatch over arbitrary memory blocks of anything?
I see. Yeah, very very cool. Saul, what are the technologies that Xnd is built on?
Yeah, so like we've been saying, there's kind of two parts to Xnd. There's the C part that just depends on the C runtime, and then there's right now there's Python bindings around that. So it's pretty cleanly divided, and actually there are three separate projects in Xnd called NDTypes, Xnd, and GUmath. And NDTypes is just the type description language, so that has a C part and a Python part. And then there's Xnd, which is that type description plus a block of memory. So that also has a C and a Python part. And then there's GUmath, which describes computation, applying some computation to those blocks of memory. So that also has the C and the Python kind of part of it. So it doesn't depend on anything really besides the languages themselves.
Yeah, excellent. Cool. Travis, who started Xnd?
Good question. I think I'm the guilty party. Having kind of had this epiphany about 3 years ago about how to actually take NumPy D types and make them more general. And I wanted to figure out, well, I didn't have any time to work on it, but I had the idea and I wanted to help get people to work on it. So I looked around, tried to hire a few people, eventually found Stefan Krah, who was willing to work on these kind of ideas. And he was a memory view maintainer, a Python core developer, talented C developer, and he was willing to kind of remotely work with me on this. I hired him in Anaconda. We first looked at Dyned to see if we could be reused. Dyned's a great library. Erwin Zaid, Mark Weeb, and Ian Henriksen have been working on that for a while. We tried to reuse it. Ultimately, didn't use any part of it and just kind of rewrote it from scratch, the ideas. And Stefan Krah has really, for the past 2 years, been working kind of tirelessly on this, really regularly on this, pretty much alone, with a couple of contributors from a few other people, up until this year when we started Quansight and started bringing more people onto the Xnd project to help it kind of develop. So I call myself the organizer of the project at this point. Maybe
I see.
Product manager, maybe kind of idea, enthusiast, and then but Stefan Krah is really the lead developer, and it's his. He's put a lot of effort to it, and he's kind of made it his own. And so he's really the core guy. And then lots of people have been contributing. Piaru, Saul, Ivan, lots of other people have been adding to it today. David Brochard did some work earlier this summer as well.
Awesome. That's great. Are there any other supported languages other than Python and C currently? I know that since it is kind of a low-level library.
That's a great question. So the original idea was to have lots of other supported languages, and we're not core of it lots yet, but XMD is still very new. I consider it, sort of just about alpha, kind of moving from alpha to beta for the Python bindings particularly. And so we did this summer when somebody reached out and said, hey, I'm a Ruby developer. I'd like to use XMD to connect Ruby to kind of build a machine learning framework on Ruby. I was very excited and said, that's super. Why don't you, let's work together and help you get that started. So there is somebody starting to the Ruby bindings. I had a conversation with Microsoft about possibly a C# bindings, XMD. Very eager to see Go, Node, Java, many other bindings where they could be using the system.
That's awesome. Yeah, that'd be great. So at this point, we're going to switch over and do a project demo just to give people a view of what XMD is and how it works. And Saul will be running that demo here. So he's gone ahead and shared his screen. It's a little thin there, Saul, if you want to.
How's that?
There. That's great. Perfect.
Okay.
So yeah, if you want to walk us through some of these notebooks you've got.
Sure. So this is this notebook is also, if you go to the XMD homepage, it's linked from there. So if you want to follow along, you can. But we're just going to look at the Python bindings here, where we're making an XMD array from a Python list. So you can see here it infers the type, which the length 5 times int64, and you can compare it to NumPy. It's a little different. XMD explicitly lists the type here when you look at an array. So here's multi-dimensional array, 2 times 2 times float 64, so it's a 2 by 2 matrix. And then you can see it's sort of similar to NumPy. So, and then maybe it would be helpful just to show, yes, you can, you can slice this. So if you take, this gives you the first row or the second row and that sort of thing. So it supports the Python slicing.
And is that giving you a view or a copy?
Yeah, that's giving you a view.
Cool.
So none of it. So it is copied here because this is a Python list, and Python list is not contiguous in memory.
Right.
So it copies it here into a block of memory. But then once it's already in that contiguous block of memory, it just needs to move the pointer around and give you this. So one nice thing about XMD is that we have strings here of variable length, as opposed to in NumPy where you can have a max length or as objects. So this is like first class. And then related to that is that we have variable length arrays. So here we see that this type here is variable. And actually internally, the type stores the offsets so that it knows exactly how big each subarray is. But in NumPy, they just become objects here, lists basically. So yep, go ahead.
Yeah, so those strings are truly ragged then up above, right?
Yes.
Yeah.
Ragged.
Okay.
So like you were saying, if I index here, then this is just doing slicing again, like you would with the rectangular array. There are also some more other types like categorical types. So here we've defined these categories, levels they're called, and then we pass them in, and so then it can store this more efficiently because it is not storing this as strings anymore. It just has to store the mapping from the strings to the categories, and then we'll just store this as ints.
Cool.
Yep. So we can look. So then this is actually when we access the type attribute, we get this NDT or ND types object. So this is sort of where you start to see the layers of abstraction, where XND is the memory plus the type, and then if you access the type, you just get this type object back.
Wow. So the type system
yeah.
is much more dynamic than NumPy's. Even already, you can see that.
It's it's more standalone, so it's
Yeah.
sort of easier to reason about apart from the data representation. Dot value here, we're just turning it back into a Python list so that we can look at it. The other thing here is Xnd has support for structs and can infer the types. So we pass in this Python list of dictionaries, and then here it infers the types there. So that's pretty nice. Yeah, and we can do slicing on this or slice down to get the actual string here. And so this is all still just a view. It's not actually copying any memory. So that's a big theme. And I know something that Travis talked to me a lot about when I was first looking at this is that we want to avoid memory copies whenever possible. So that's what drives a lot of this. And on that theme, we can take some NumPy data from using the buffer protocol in Python and wrap that in Xnd basically. So here we've created some data in NumPy and we use the from buffer. And then this won't, now we don't have to copy it when we pass it in here.
Cool.
Yep. And you can do the same with some arrays in NumPy. And then one other thing is just that Xnd does do type inference for what you pass in, but if you would like to speed it up, you can pass in the type explicitly. So here it's n times in64. I guess these are running still, but it's a bit faster to do it this way so that it doesn't have to traverse the whole Python list and figure out, are they actually all integers? So,
Gotcha.
this finishes. Any questions so far on the sort of basics of this part?
So for the structured array part, or if we have any questions from the chat, we'd be happy to take them now. But that's really interesting. It seems like it's interpreting a structured array kind of in the same way that it interpreted a dictionary or the record array.
Here.
Yeah.
This example.
Yeah.
Yeah.
In terms of the type itself, the type looks very similar.
Yeah, it's the same. So it'll be the same in memory as it would be if you passed in a Python list of dictionaries.
Right. That's very cool.
Yeah. So now I wanted to just look at a few examples of the Numba integration. So this is like a very kind of silly mean function that takes in an Xnd list and returns the mean of it. I hope, unless there's some error there. So we can time this is just in Python, right? So it'll call this the C bindings when you're accessing the API here, but the rest of this is in the Python runtime, all the looping and everything. So then we can njit is imported from Numba, so it's we can jit this function, and it'll go a little bit faster. And that's because instead of living in Python land, this all gets translated to LLVM, and it doesn't have to do the same kind of garbage collection and that kind of arithmetic. So this is still calling the xndc library when it's JITted, but it's not using the Python bindings for Xnd anymore. But it feels the same for the Python user.
I see.
Yeah. And then the other option that we have, so this is just taking some Python code and JITting it. The other option we have is to register kernel. So here we see this is an ND type signature. So this is a function signature. And it's saying we're taking some list of ints and we're returning a float here. And this ... means that we're going to allow broadcasting. So this is sort of like there could be some outer dimensions here and we don't really care about them. And we just want this inner dimension, if that makes sense. So this first x here will be this n times int64, and this result is just this float64 scalar. So it's similar to the above code, but now we can use it on, so it will broadcast. So here we have 2 lists, and it'll take the mean of each of those lists.
Right. So in that example right there, that return type, is that a special scalar type for the XND result, or is that a special, or is that just a normal? That's a 0-dimensional XND.
Yeah, there isn't a scalar type. It's just a 0-dimensional array, and you see where it's a little funny here, but we're setting, so this result is a scalar XND type, and we want to set its value to be 0. So we're saying the empty tuple means indexing. It's like the scalar.
Oh, yeah. Right.
Yeah. So and this gets passed in here so that when you're doing this, when it's applying this function, it can allocate this full return array here, and then just pass in the pointers to this kernel. So that's why it needs to be passed in. It can't just be returned, the result, so that this result, first points to this value, this area here, and then points to this area, so that you don't have to copy the result after you return it, basically.
I see. Clever. Cool.
Yep. So that's my demo. Let's see.
Anyone have any questions from the chat so far?
You decided not to show us the matrix multiply?
Yeah, I could. Yeah, actually, am I still presenting? It's right here, I guess. So this is a little more code, but here we've defined a kernel that does matrix multiplication for ints and floats. And we can do it on some simple data here. But then we can also, I don't know what I did here, build up some big matrix of matrices, or list of matrices, basically. And then we can apply it to this as well. Let's see.
So Jonathan from the chat asks if this works on ragged arrays.
This here?
I believe.
Yeah, it works on ragged arrays. So we can define a function here, and then we can define a function and then apply it to a ragged array, and it will be broadcast to the inner part of that. Like if we wanted to have a ragged array of matrices and then multiply them, that's something that we could do with this.
Oh, that's cool. All right. Well, thank you very much, Saul. That's a great introduction and demo. Travis, did you have anything you wanted to add before we move on?
No, that's excellent. I mean, you can kind of see that it's optimized for a developer. I mean, some niceties of adding the dot value. There's things that we haven't tried to eliminate yet. It's a lot of times NumPy tries to make things easier for the user by eliminating things that create guesses for the developer. There's these sort of 2 modes in Python land because it merges both developers and users. There's sort of, I want to use this and not think about some of the details. And so the library, the developer wants the library to be very clear about what it does and not do more than it says. Like be very exact and very specific.
Right.
And so you can kind of see XND is leaning more towards, I'm supporting developers. Right. So it's going to be, here's the API, here's what it does, here's what it doesn't do. And then to support users, you might wrap it a little bit with some niceties. And that's sort of
an example of that is you can't use the Python add on 2 XND containers. Right. It's not defined. So you'd use the geomath add kernel on those 2 XND containers. But it makes sense to have a higher level, kind of wrapper container that supports maybe the Python methods that just forward that. But
right, and that's kind of one area we're working on right now is what should that higher level interface look like?
I see. Yeah, interesting. Okay, well, that's very cool. So at this point, we're going to move on to our discussion of the roadmap for XND, and this is the meat of the episode. And so we're going to talk broadly speaking about where the project is going, and specifically there's a XND roadmap that you can go and look at, I believe on the XND website and also at quansight.com/projects. And we're going to just go through, the first few of the roadmap items in detail, and we'll see how many we get through. First up is GPU support. Oh, and I should mention before we dive in, these are areas where you as a developer can step in and contribute, or you as a company could step in and help fund. So these are things that are kind of broadly speaking in scope for the project, and we'd love to, and XND would love to have help with. So yeah, first up is GPU support. Did one of you want to take that? Describe that in detail.
Start with that a little bit, probably not in detail. So David Brochart had been working on the XND GPU integration. So there's a repo, xnd-gpu, that you can go check out that has some preliminary work there. It has some kernels, and it's able to execute those on the GPU. I know that we were sort of it's a prototype, and it is one approach, and I think we're sort of now trying to figure out how do we go from here? What are the learnings, and how do we move forward in terms of integrating this with the core of XND?
So those are things like cuBLAS and CUDA, and things like that, and like the basically the GPU, the customized GPU compute kernels. Is that kind of
right? What happens when your data is on the GPU and you want your compute to be there as well?
Right.
So how do you register that? What does it look like? What does the C-level side look like? Are there, how do we support that?
Right. What's the IPC and navigating that? That's cool. Yeah, it's really exciting. Definitely an important feature. The next roadmap item is the Lapack and MKL kernels and kernel generators. Travis, did you want to speak to that?
Right, I can talk a little bit to that. This is basically, I was talking to someone about XND, and they said, so where are all the kernels, right? They kind of wanted to know, because a lot of people look at NumPy and go, oh, cool, I have all these functions for me to call. And so your first instinct, you look at XND, is, well, where are the functions I can call?
Right.
Well, it's true. We sort of have a system for building functions. Well, now you got to start making them so that people have access to the library of functions to call. And part of that work is the work that Saul showed with Numba integration. Make it easy to build them with Python code, right? So you can write your own kernels very easily. And then the next is, can we automatically generate kernels that call out to low-level libraries, Lapack, MKL. This is sort of the direction SciPy went. Let's build the NumPy container, and then SciPy and then F2Py auto-generated a bunch of tools for talking to this container. So that's kind of what that is can we not only make these functions exist, but can we create tools to automatically generate them for other libraries, auto-generator, auto-wrapper tools. Right.
Yeah, so that's a nice segue actually into the next roadmap item, which was Numba integration. It seems like from your demo, Saul, that's pretty much there and working, or is there more to do?
Yeah, it's working. There's more to do on a couple fronts. So for the past couple weeks, I've been looking at the how we're doing memory allocation in Numba. So I'm moving to using Numba's reference counting allocator. So that's a little bit of work, and I'm still ironing out the seg faults. So, because it was working sort of before that. So once that is kind of, and there's nothing, I don't see any huge problems in the way. It's just a question of making it happen.
Well, are there big efforts remaining that would need like large scale funding or anything on the Numba side or the Numba and XND side?
So I think it would be more on applications there. Like the core of XND is pretty small, so it's not like it's a ton to wrap. It's more like, if we want to do string processing, for example, to support some string kernels, that could be really useful, I think, and that sort of thing.
Right. Yeah.
Generally, the area, one thing I'll say generally is XND is in a state where it's going to be driven by applications. So kind of wanted to get the basics together, and there's some places to keep improving, but mostly it's, okay, what are the applications? What are the use cases? Anderson this summer, one of our interns, did a really great connection to data frames. Showed how you could use XND to build these custom types and data for pandas. So that's one potential application. There's another one, can we build custom D types in NumPy with XND? Like, what are the integrations we can make? And then there's a colleague who's doing awkward arrays that could potentially use XND. We want to start driving user stories and then have XND be developed by those developers.
What is an awkward array? Just slow.
That's a term coined by the high energy physics community. Basically, have tons of these nested high dimensional data structures, that ragged arrays, lots of different kinds of data types, and so it doesn't really fit cleanly into the NumPy model. And so
Gotcha.
he came up with the awkward array concept, and it does, it maps to what we're trying to do with XND. XND should make that easier, the ability to build a high-level awkward array. And he wants to build a high-level interface so that users can use it from the Python side. So I would say, a high-level interface to XND to support the awkward array use cases is a useful application of XND potentially.
Right. Okay, that'd be cool. Next up is the serialization. Is there a serialization effort that's ongoing, or is that little plan? Is that something that the XND community would like help and funding to do, or where is that story right now?
What do you think, Saul? Do you want me to take this, or do you have an idea?
Yeah. So serialization, one thing we've been talking about recently is on disk formats like CSV, JSON, etc. And how do you get those into XND efficiently?
So more deserialization.
Yeah. So that's one. That's kind of one area.
Serialization is kind of. XND can map to any disk format, right? So the serialization concept really comes down to, well, do we want to compress it before we store it? Like, do we want to do some transformations on the data and then store it? Are there integrations with familiar formats, Parquet, other sorts of ideas? And then the deserialization is a big one. I think JSON parsing is another really good application of XND. You can go from a JSON file to an XND data structure pretty quickly.
Right. Jonathan just asked about HDF5. Yeah, that's
yeah.
So yeah, there need to be work there, basically.
Work to map
supporting these formats.
Yeah. Yeah, very cool. So I think there's a few other items that we've got up on the roadmap. So like translating arrow types and plasma storage and threaded loops and FPGAs. Before we move on from our roadmap discussion, did anyone have any thoughts about, or you want to get any thoughts in about some of these issues?
I'll just mention the plasma storage. Plasma is an example of something I call a data fabric. Other people do too. Like the idea of, hey, I can have all my data living in a live multi-cluster memory system, and then I just want to be able to point to a pointer, and then understand that pointer. That's what XND lets you do, is just point to any data and then understand it as a pointer. Plasma kind of gives you this. It's like this approach to having an in-memory data structure, or in-memory data that's just live. So it's the anti-serial, just instantiate, right, and then point things to it until you can. Then when it comes time to copying, if you need to copy data over and move it, okay, maybe you want to compress, put it in a compressed format, move it around.
Right.
On the other point of a high-level array API, that's something that we've been talking about more recently and starting some efforts around. The UArray name is what we're going with right now for that. So that's sort of like XND provides these sort of implementations. So what if you actually want to compose this kind of array operations in Python and do it in a way that's agnostic to backend and that sort of thing. So that's what we're looking at going forward on that effort. But it'll be, not directly tied to XND, although obviously there'll be collaboration.
Yeah.
Yeah.
Look for a webinar episode on UArray in the coming months, maybe hopefully by the end of the year.
Yeah, that sounds fun. Happy to do one on that. All right, well, great. Thanks for giving us a very fast tour through the roadmap. And yeah, just for our listeners out there, just remember again, these are places where you can dive in and help, either in code or with funds. So at this point, we're going to open it up to user questions. So we had one question come in about comparing XND to the buffer protocol / C types. And while Travis and Saul are answering that, if you want to ask more questions in the chat here, please feel free. So, and hopefully we'll get to those right after this one. So.
Yeah, so XND you're thinking correctly in terms of the buffer protocol, C types. So the buffer protocol was actually one of the answers to solving the split with NumArray and numeric. One was NumPy, and the other was enhance the buffer protocol, so that we sort of fix it twice concept. Now, effectively, the buffer protocol, what we're trying to do at XND is essentially make the buffer protocol cross-language, not just in Python, but across multiple languages have a common way to talk about data. So in some sense, it's taking the buffer protocol and spreading it across the computer science ecosystem. And then C types, I would say it'd be nice to have a translator between a C types description and an XND. And I think ND types, I'd like to see it grow quite a few more. It's not necessarily on the roadmap right now, but I'd love to see it. I'd love to see ND types be able to consume and export lots of different descriptors of data. C type, struct module syntax, protocol buffers, flat buffers. There's all kinds of other ways to describe data. And I'd like ND types to be able to consume them and export them and kind of be just a way to translate between data specifications.
Yeah, it's great.
Thanks. That's actually my question.
Funny. Any others? I didn't see any other questions come through other than Jonathan's from during the actual webinar itself. So I think if you have more questions, feel free to just reach out to us or ping Travis and Saul on Twitter or something. And
there's a Gitter channel. It's open public Gitter channel. XND is developed in public and developed in the open. So there's a GitHub page. You can file issues. There's a Gitter channel. You can just post a question. And you can, there really isn't a mailing list, I guess. We've talked about that in the past. But I understand the young kids don't do the mailing list these days. But, I'm on Facebook and mailing lists, and everybody else is on Instagram and no mailing lists. So it's kind of an interesting cultural switch. But there are ways to get a hold and to participate and to jump in. XND is really looking for users, developers. We want to develop XND according to the needs of people that find that have these sorts of problems. And I see people with these sorts of problems. So part of it is getting the word out that XND is here. It can help. You don't necessarily have to reinvent all these yourself. You don't have to, if you're finding yourself struggling with some aspect of NumPy, come look at XND. I think we can help.
Great.
We also have weekly chats, like Hangouts, and those links are posted to the Gitter. So if you want to, anyone's welcome, jump in and say hi or just listen in.
Excellent. So that's great. All those excellent ways to contact you guys. So now we're going to enter our world famous rant section. So each person gets about 15 seconds to get on their soapbox. Travis, go ahead.
Yeah, my soapbox is to become a sustaining member of NumFocus. Using NumPy or SciPy or Pandas or Jupyter or any of the projects that Julia, Stan, ROpenSci, there's actually many projects that NumFocus is helping to support and sustain. See if you can contribute $5 a month, $10 a month, $100 a month, right? Like just a regular contribution to NumFocus as a sustaining member goes a long way. And then you become a part of the action, part of the solution to how we're going to sustain open source.
Hear, hear. Saul?
This is a little different, but I think it's a good contrast. In these spaces, we're often very heady. So my 15-second soapbox is silence, and it's engaging with other people without having to talk to them all the time. So if you're in if you're in a social situation, just seeing how you guys can communicate without actually talking. Yeah.
Yeah. Great point. I think for my soapbox today, I've been doing a lot of spackling and laying of floors and everything. And I just want to say that carpentry is not like software carpentry at all. Fundamentally different. All right. Well, thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including XND, you can find all of our project roadmaps at quansight.com/projects. The XND website is xnd.io, where you can go learn more about XND. And Travis, where can people find out about you?
T Oliphant Twitter, technical discovery blog post, and the Quansight pages. I'm definitely we're pushing hard on Quansight Labs right now. So if you're interested in contributing to these, to like a lot of different projects, including the ones that we're sustaining with NumPy, SciPy, and so forth, put me in touch with somebody or organization that can help fund Quansight Labs.
Excellent. And Saul, where can people find you?
Yeah, on Twitter at sjanabrook. It's probably the best way.
Awesome. So thank you very much, Travis and Saul, and join us again, all of our viewers, next episode for a rousing discussion on SymPy. And thank you very much for watching, and thanks for listening.
Thank you.
Bye-bye.
Bye, everybody.
Bye.